Okay, so in this lesson we're going to be talking about defining and using exponents and the order of operations. So we're going to look at exponents, we're going to look at exponential expressions, and then we're also going to look at order of operations in this part of the lesson. Alright, so let's discuss this idea right here. Suppose I had this product. Suppose I had 2 times 2 times 2 times 2. Alright, suppose I had that. Now, notice that 2 is listed as a factor 4 times. So 2 is listed as a factor 4 times. So I can write this in exponential notation. Exponential notation. So the way I'm going to write this is going to be 2. And remember, 2 is being multiplied by itself 4 times. So 2 is a factor that occurs 4 times. I'm going to write this as 2 to the 4th. Okay, so let's talk about this 2 to the 4th for a moment. So this 2 right here, that's called the base. So the base is your factor. The base is the factor. So a factor here is 2, and it occurs 4 times as a factor. The 4 is the exponent. The 4 is the exponent. So notice that 2, the factor 2, occurs 4 times. Okay? Now, this 2 to the 4th, this expression right here, is called an exponential expression. Exponential expression. Alright, so 2 to the 4th is called an exponential expression. Now, what you want to do with these is you want to evaluate these exponential expressions. So let's talk about evaluating exponential expressions. All right, so evaluating exponential expressions. Okay, suppose I had this. Suppose I had, number 1, suppose I had 4 to the 2nd power. 4 squared, 4 to the 2nd power. All right, so remember the base is 4. So your base is 4. There's your base right here. So that's your factor. So my factor 4 occurs, and the exponent tells you how many times it occurs. So what that means, 4 to the 2nd power, or 4 squared, what that means is 4 times 4, which is 16. So the answer would be 16. So when you evaluate this exponential expression, you're going to look at the base, which is your factor, and it occurs as a factor the exponent number of times. So 4 squared means 4 times 4. Don't make the mistake and say that 4 squared means 4 times 2. That's not true. That's incorrect. All right, so 4 squared does not mean 4 times 2. 4 squared means 4 times 4. So this 2 right here, the exponent 2, indicates that it occurs 2 times. Okay? All right. Number 2, suppose we had 3 to the 4th power. All right, so 3 to the 4th. Well, again, what that means is, remember your base is 3 and your exponent is 4. So what that means is that 3 is going to occur as a factor 4 times. So notice 3 times 3 times 3 times 3. And so when I multiply this out, 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So 3 to the 4th is going to equal 81. So there's your answer. Okay? 3. Suppose I had, let's say, 2 fifths. So I had this fraction squared. So 2 fifths squared. Okay, well, so again, 2 fifths is your base. So there's your base. This is your base. And then 2 is your exponent. So this 2 fifths, which is my base, so it's a factor that's going to occur 2 times. So that's how it looks. 2 fifths times 2 fifths. And then you're just multiplying these fractions, so you multiply the numerators. 2 times 2 is 4. And then the denominators, find that product. 5 times 5 is 25. So you get 4/25 as your as your answer for 2/5 squared. Alright, now suppose we had this one, number 4. Suppose I had, let's say, 1.2 squared. So I have this fraction, this decimal right here. Let me go ahead and move this up. So you have 1.2 or 1 2/10 squared. So again, what that means is 1 2/10 times itself, 1 2/10. Okay, so using a calculator, you just multiply that out and you get it very easily. But if you don't have access to a calculator, remember how you do this. So 1.2 times 1.2. So 2 times 2 is 4. 2 times 1 is 2. 1 times 2 is 2. And then 1 times 1 is 1. So then you add those digits. So you get 4, 4, 1, 2 decimal places. So the answer is 1.44, or 1 44 hundredths. So 1.44. So if your base was listed as a decimal, leave your answer as a decimal. Don't change any of this to a fraction. Just leave it as a decimal. And so you get 1 44 hundredths. Okay. All right. Now, so that's going to take care of the first part. So we looked at what is exponential notation, what is exponential expression. We talked about the idea of base. We talked about the idea of exponent. Okay, now let's talk about the idea of order of operations. Order of operations. Okay, so when using the order of operations, there can be situations where we're going to use grouping symbols. So you may see something like this. You may see something like 2 plus, and then in parentheses you could see 3 minus 4 squared, and then plus 2 plus 1 divided by, let's say, 6, something like that. All right. So in this case, to evaluate this expression, you would need to use the order of operations. Okay, order of operations to do this. Okay, now the quickest way, or the easiest way that some students use to remember the order of operations is this. So they remember, please excuse my dear and Sally. So just remember that for the order of operations. So please excuse my dear and Sally. So let me go ahead and write this down right here. Please excuse my dear, and then Aunt Sally. Okay, so notice in the spacing here, so P is by itself, E is by itself, MD is together, see the spacing here, and then AS is together. Okay, now, so again, P, please excuse my dear Aunt Sally. All right, but mathematically, the P here stands for parentheses. Parentheses. Or any grouping symbol. Keep that in mind. Any grouping symbol. So you can have something other than parentheses. And so the grouping symbols that you would see could be parentheses. It could be brackets. It could be braces. Oops, sorry. It could be braces. It looks like this. All right, so parentheses. Parentheses. Brackets, or braces. So those are the more common ones that you would see. Now, in a little while, you're also going to see the fraction bar. So the fraction bar can also serve as a grouping symbol. You're going to see this in a few minutes. The fraction bar can also serve as a grouping symbol. So all this right here would represent grouping symbols, and that's what you would deal with first. Okay, so the E here stands for exponents, so that's your next level. All right, so when evaluating expressions using the order of operations. So the parentheses or grouping symbol has a higher priority over anything else. Then the next thing is exponents. All right. Then the next priority is multiplication, division. I'm going to write this right here. Multiplication, division. And you do that from left to right. Okay, so what that means is whatever you come across first in terms of multiplication and division. So if you come across division first as you go from left to right, or if you come across multiplication first as you go from left to right, you do that operation first. Okay, now this right here does not mean you do multiplication first all the time. The M here is only listed first because of our wording. Please excuse my dear Aunt Sally. All right, but what that means is that as you go from left to right, if whatever multiplication division you see, you do that first as you go from left to right. Okay, same thing for addition and subtraction. So addition and subtraction, put that right here. Addition and subtraction you can do that from left to right as well. From left to right. Okay, so if subtraction occurs first from left to right, you do it. If addition occurs first from left to right, you do it. Okay? All right, so please excuse my dear Aunt Sally. All right, so in your book, they basically have this written down. So let's kind of look at the order they have here. So it says perform all operations within grouping symbols first, starting with the innermost set. So we'll look at something in a little while what they mean by innermost set. Then we evaluate exponents. So we do grouping symbols, then we do exponents, then we do multiplication and division in the order from left to right, and then we do adding and subtracting in the order from left to right. Okay? So please excuse my dear Aunt Sally. All right, so let's look at some examples with these. Okay, so let's look at this example first. We'll start with a simple example, and then we'll look at some grouping symbols. All right, so let's suppose I had this. So the directions will say simplify each expression. Okay, simplify each expression. All right, number 1. All right, suppose I had 5 plus 6 times 2. Now that's the easy kind, 5 plus 6 times 2, because there are no grouping symbols. So since there's no grouping symbols, it's easy to deal with. There are no grouping symbols, there are no exponents. So basically, you're going to multiply first and then add, because that's what the order says. I multiply, right here, multiplication has a higher priority than addition. So multiplication, division first, addition, subtraction last. All right, so I'm going to do multiplication first. So all I see is addition and multiplication. Those are the only two operations I see. So I'm going to do multiplication first. So remember the order. You must do multiplication first. So this becomes 5 plus 12. All right, and then 5 plus 12 is, you do addition next, you get 17. So the answer is 17. Okay, so that's going to go in the blank if this was a worksheet. Okay, number 2. All right, number 2. Suppose you had this. Suppose you had 4 times 8 minus 6 times 2. Suppose we had that. All right, so again, notice, again, no grouping symbol, no exponent, so this is the easy kind. The operations, notice the operations though, multiplication, subtraction, multiplication. All right, so according to the order of operations, I must do multiplication before I do subtraction. But notice that in this case, there are 2 multiplication symbols. So according to this, I do multiplication division as I go from left to right. So from left to right. So as I go from left to right, I see this multiplication first. So I do it. So 4 times 8 is 32. Okay, so I'm doing one thing at a time, write everything else over. All right, so one thing at a time. So 4 times 8 is 32. Now what I'm left with is a subtraction and a multiplication. So according to the order of operations, multiplication has higher priority than subtraction. So I do this product next. So that becomes 32 minus 12. And then finally I do subtraction. So 32 minus 12 is 20. So there's the answer for number 2, 20. Okay, let's look at this one. All right, so number 3. Okay, so number 3, let's suppose you had 18 divided by 3 times 2. 18 divided by 3 times 2. Now this confuses students quite often. It's a very easy, not easy, but it's a common mistake to make. Let me use the word common instead. Remember, here you have division in multiplication. Many students seem to think that multiplication has higher priority before division. That's not true. Remember, and the reason they think that, for the most part, that's not always the case, but for the most part, the reason they think that is because they see M listed first. But again, the M's listed first because of our words. My comes before dear in the sentence. Okay, but remember, you must do this from left to right. You got to do it from left to right. So when I read this, I see a division and I see a multiplication. So according to our order of operations, since I came across division first, I must do division first. So 18 divided by 3 is 6. So I get 6 times 2. And the only operation left is multiplication. So I do this multiplication, I do this product. So 6 times 2 is 12. Okay, number 4. Okay, number 4, let's suppose you had 2 plus, and then 5 minus 2 plus 4 squared. So 2 plus 5 minus 2 plus 4 squared. Okay, so if you look at this, now I have grouping symbols, and I also have an exponent. So according to order of operations, the grouping symbols have higher priority than anything else. So basically, I have to do the grouping symbol first. So here's my grouping symbol right here. So I do what's inside the parentheses. All right, so I look at the grouping symbol. There's only one operation inside the parentheses, and I do it. So 5 subtract 2 is 3. So I get 2 plus 3 plus 4 squared. That's what I end up with at this point. Now look at what you have. You have addition, addition, and exponent. So according to our order of operation, exponent has higher priority than addition. So I do exponent next. So remember 4 squared. So let's think about what 4 squared is based on our earlier discussion. 4 squared, 4 is your base. All right, 4 is your base, and the exponent tells you how many times this base occurs as a factor. So this base 4 occurs as a factor twice. So that means 4 times 4, which is 16. So this right here is going to be 16. So notice I'm doing one thing at a time. So I did this first, and now I'm doing this. All right, so I get 2 plus 3 plus 16. And now the only thing left over is addition. So I'm going to just go ahead and do it from left to right. 2 plus 3 is 5, and then I get 5 plus 16, and 5 plus 16 is 21. Okay? All right, number 5. Okay, suppose now I had this. Suppose I had 5 times 3 squared. 5 times 3 squared. So again, remember the operations I have here. So it's good I just look at the operation I have here is multiplication and exponent. According to our order of operations, remember this right here, according to order of operations, exponent comes before multiplication. So when I look at this exponential expression right here, 3 squared, remember 3 squared, if you need to think about it and write it out, write it out. 3 squared means 3 times 3, which is 9. And so I get 5 times 9, and so 5 times 9 is just 45. Okay, number 6. All right, number 6, suppose you had this. Suppose you had, let's see, All right, suppose you had 6 minus 4 divided by 9 minus 2. All right, so remember a while ago when we had the discussion, we said that our grouping symbols can be represented as parentheses, brackets, braces, and then we said a fraction bar. Okay, so right here I have a fraction bar. See this fraction bar? So I can think of this as a grouping symbol itself. Okay, so in my numerator, so you look at this in terms of a numerator and a denominator then. In my numerator, I only have one operation. That operation is a subtraction, so I deal with it. 6 subtract 4 is 2. In my denominator, I have 9 subtract 2 is 7. And then if I can reduce, I reduce, and I can't here because the GCF of both of those is 1. And so there's the answer. So this expression right here, 6 subtract 4 divided by 9 subtract 2 is just 2/7. Number 7. Okay, well, suppose we had this now. Suppose we had 19 subtract 3 times 5 divided by 6 minus 4. All right, suppose I had that. Okay, so again, I have this division, so I'm going to think of this as a grouping symbol. So I'm going to look at the numerator first. And then if I look at the numerator first, here's my numerator. Let's think about this for a moment. My numerator is 19 subtract 3 times 5. That's my numerator. And so just like we did previously, I have a subtraction and multiplication. So according to the order of operations, I got to do multiplication first. I got to do this first. So this means 19 minus 15. 3 times 5 is 15. And now I do subtraction. So 19 subtract 15 is 4. All right, so that's your numerator. So my numerator is 4. So that's where this came from. Okay, so right here, that's where that came from. My denominator now, 6 subtract 4, that's easy. 6 subtract 4 is just 2. All right, now don't leave your answer like this because you notice that 4 divided by 2 I can reduce, and that's just the number 2. 4 divided by 2 is 2. Okay? All right, let's look at number 8. All right, so number 8, suppose we had this. Okay, suppose we had, let's look at another division grouping symbol. All right, suppose we had, in my numerator, I have 3 plus 3 times 5 plus 3. And my denominator, I have 3 squared plus 1. All right, so here's my grouping symbol. I have the division bar as a grouping symbol. So I'm going to look at the numerator first. Look at the numerator first. So I'm going to rewrite the numerator. My numerator is 3 plus 3 times 5 plus 3. And so I'm going to use the order of operations on this part now. So notice I have addition, this is multiplication, and this is a grouping symbol with addition within it. So remember, I got to do a grouping symbol first. So my grouping symbol is parentheses. So I do what's inside the parentheses. There's only one operation, 5 plus 3, so I do 5 plus 3. So 5 plus 3 is 8. So I get 3 plus 3 times, that's multiplication, times 8. And then I'm left with addition and multiplication, so I do multiplication next. So I get 3 plus, and then 3 times 8 is 24. And then finally, 3 plus 24 is 27. So that's my numerator. So my numerator is 27. Now let's get the denominator. The denominator, I get 3 squared plus 1. That's my denominator. So let's use the order of operations on this denominator. Well, I have an exponent and an addition. So exponent comes first. So 3 squared means 3 times 3, which is 9. And 9 plus 1 is 10. So I get 27 divided by 10. And I can't reduce that. Cannot reduce this. So leave it as 27 divided by 10. Don't change it to a mixed number. Leave it as a fraction. All right, so that's number 8. Okay, number 9, suppose you had this. And number 9, suppose you had, okay, so let's say you had the absolute value of 6 minus 2. Now remember, this means absolute value. If you see those two bars right here, that means absolute value. So 6 subtract 2, absolute value of 6 subtract 2 plus 3, and then 8 plus 2 times 5. So let's suppose we have that. Now let's kind of review something about absolute value for a moment. Okay, absolute value. All right. So remember, in a previous course, the absolute value of a number, so the absolute value of, let's say, A, is the distance that A is from 0 on the number line. Okay? So the absolute value of A is the distance that A is from 0 on the number line. So for example, let's suppose we looked at the absolute value of, let's say, 5. Absolute value of 5. So on the number line, here's 0, and remember, positive 5 is positive. See, I'm taking the absolute value of positive 5. So positive 5 is here. And so I'm interested in this distance, the distance from 0 to 5. Well, in terms of units, the number 5 is 5 units from 0. So the absolute value of 5 then is 5. Okay? The absolute value of 5 is just 5. So the absolute value of 5 means the distance that 5 is from 0. Well, 5 is 5, the absolute value of 5, so 5 is 5 units from 0. Well, what if you had this? What if you had the absolute value of a negative 4 instead? All right, well, same idea. So here's my number line. Here's 0. Here's negative 4. So in terms of distance, in terms of this distance here, remember the absolute value measures the distance that this number, negative 4, so this number is from 0. Well, negative 4 is 4 units from 0. 4 units to the left. So it's 4 units from 0. So the absolute value of negative 4 is 4. So notice the absolute value of a number besides 0, the absolute value of a number other than 0 is just the positive component. So the absolute value of 5 is 5, the absolute value of negative 4 is 4. So don't make the mistake and say the absolute value of negative 4 is negative 4. That's not true. Remember, the absolute value measures the distance that a number is from 0. And so when we talk about distances, for the most part, the distance is measured in positive terms. All right, so the absolute value of 5 is a positive 5, the absolute value of negative 4 is a positive 4, and the absolute value of 0 is just 0. Okay? All right, so let's look at this one. So remember, this fraction bar right here is considered a grouping symbol. So I'm going to look at the numerator first. So let's look at this numerator for a moment. I have the absolute value of 6 minus 2 plus 3. Now, think of the absolute value bars as grouping symbols themselves. Even though it's not parentheses or it's not bracket, it's not braces, think of the absolute value bars as grouping symbol. So since the absolute value bar, think of this in terms of a grouping symbol, I've got to do what's inside the parentheses, what's inside the absolute value bars first. So 6 subtract 2 is 4. So I have the absolute value of 4 plus 3. So I have this this right here is this. And now the absolute value of 4, remember, is a positive 4. So the absolute value of 4 means what is the distance that this 4 is from 0? Well, it's just 4 units from 0. And so 4 plus 3 is just 7. 4 plus 3 is 7. So that's your numerator. So your numerator is 7. Okay, let's talk about the denominator. So I'm going to write the denominator right here. So 8 plus 2 times 5. That's my denominator. Well, according to the order of operations, now notice the operations here, I have 2 of them, addition and multiplication. So according to the order of operations, I have to do multiplication first. So it becomes 8 plus 10. And so 8 plus 10 is just 18. So that's my denominator. So that goes here. And there's nothing you can do with this. You can't reduce it, so it's just 7/18. There's your answer. Okay, let's look at this one. All right, number 10. Suppose you had this. All right, number 10. Suppose you had 6. Okay, again, I have a fraction bar. So 6 plus the absolute value of 8 subtract 2 plus 3 squared. And then my denominator, I have 18 subtract 3. That's my denominator. So 18 subtract 3. Okay, so let's look at the numerator first. I'm going to rewrite the numerator right here. So here's my numerator. I have 6 plus the absolute value of 8 subtract 2 plus 3 squared. Okay, so I have addition, I have exponent, and again, remember, think of the absolute value bars as a grouping symbol. So in terms of the order of operations, I have to do the grouping symbol first. So this right here, and there's only one operation within the grouping symbol, so do it. 8 subtract 2 is just 6. So you had 6 plus the absolute value of 6 plus 3 squared. So all I did was what was inside the grouping symbol, the absolute value bar. So 8 subtract 2 is 6. So I get the absolute value of 6 here. Now let's take the absolute value of 6. Well, the absolute value of 6 is just 6. So 6 plus 3 squared. Okay, now let's take care of the exponent. 3 squared, remember, means 3 times 3, so that's 9. So I get 6 plus 9. And then all I have left is addition. So let's just go ahead and do it from left to right. 6 plus 6 is 12, and 12 plus 9 is 21. So that's the numerator, though. Remember, that's the numerator. So that becomes 21 divided by, and then in the denominator, there's just one operation. 18 subtract 3 is 15. So at this point, I have 21 divided by 15. Now, the directions will indicate that you need to simplify this as much as possible. So if you look at 21 and 15, they both have a 3 in common. All right, 21, 15. So let's think about this for a moment. I'm going to go ahead and rewrite this over. So since they both have 3 in common, you're going to say 21 divided by 3 and then 15 divided by 3. In your mind, that's what you're thinking. So 21 divided by 3 is 7, and then 15 divided by 3 is 5. So the answer is 7/5. Leave it as an improper fraction. Don't write this as a mixed number. Just leave it as 7/5. Okay? All right, number 11. Okay, so number 11, let's suppose you had this. Suppose you had 2 times 5 plus 2 times 8 minus 3, parentheses, and then bracket. Okay? All right, so here, remember, in all the others part, if you had a grouping symbol, you only had one. But notice here, you have 2 sets of grouping symbols. You have a bracket, and you have parentheses. Okay, so look at the outer bracket for a moment. Look at the outer grouping symbol for a moment. So here's your outer grouping symbol. So what that means is that you got to do the inner part first. So you have to do this first right here. So you look at what grouping symbols on the outside, and then you do what's on the inside first. So I'm going to go ahead and rewrite this inside part first. So here I'm going to rewrite it here. So 5 plus 2 times 8 minus 3. Now again, according to our order of operations, I have addition, multiplication, and our grouping symbol. So I deal with the grouping symbol first. There's only one operation within it. It's a subtraction. So 8 subtract 3 is 5. So this right here is going to be a 5. So you have 5 plus 2 times 5. And then notice I have addition and multiplication. So according to the order of operations, I'll do multiplication first. So you got 5 plus 10. And then the only thing left is addition. And 5 plus 10 is 15. Okay, now remember, that is just this right here. So then this becomes 2 times 15. All right, so if you want to put this in bracket, you can, but that's this right here. Just keep in mind that this 2 times and then bracket 15 really means 2 times 15. And so 2 times 15 is 30. That's number 11. All right, let's look at 12. In 12, suppose we had this in 12. Suppose we had 1/4 times 2/3 minus 1/6. Suppose I had that. So 1/4 times 2/3 minus 1/6. Okay, in this case I'm dealing with fractions, but no big deal. I can deal with fractions. Notice though the operations are multiplication and subtraction. So according to order of operations, I got to do multiplication first. Now, in this case, if I go ahead and cover this part up right here, notice in a previous course, when you multiplied these two fractions, you could have reduced first. So you could have said 2 and a 2 is 1, 2 and a 4 is 2. 4 divided by 2 is 2, and then multiply it out. If you didn't see this, it's no big deal. If you did not see it, you would just say 1 times 2 is 2, 4 times 3 is 12. So I get 2/12 minus a 6. Okay? And then notice the 2/12 here you can reduce. You can reduce it in this case. Now I want to mention something first. I'm going to go ahead and rewrite this in a little while. Okay, so let's suppose you saw that you could reduce this. So 2/12, remember they're both divisible by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. So I get 1/6 minus a 6. And so 1/6 minus a 6 is just 0. So you get that. All right, here's the point I was going to make, though. Let's look at this right here. You could have also, I'm going to put the word or here, you could have also say, all right, I'm just going to leave it as 2/12. Okay, no big deal. You can leave it as 2/12. But whenever possible, it's usually much more helpful. I say usually now, usually much more helpful if you reduce. But let's just leave it 2/12 for a moment. Okay, let's remember something from a previous course. So when adding or subtracting fractions, remember you got to have the same denominator. Well, these denominators are different. They're not the same. So you got to find the least common denominator. So the least common multiple of 12 and 6. So the least common denominator of these two fractions is 12. So the least common multiple of 12 and 6 is 12. So 12 is the smallest number that 12 and 6 will go into. That's what that means. So 12 goes into 12 and 6 goes into 12 evenly as well. Okay? Now, a common denominator could also be 24. A common denominator could be 24 because 12 goes into 24 and 6 goes into 24. But remember, you don't want to use just any common denominator. You want to use the least. It makes things easier if you use the least. Okay, so let's say 12. Well, the least common multiple is 12, so my least common denominator is 12. So I'm going to write two equivalent fractions. I need to write equivalent fractions now with that denominator of 12. So 2/12 is the same as what over 12? Well, since the denominators are the same, that means the numerators have to be the same. So 2/12 is equivalent to itself. Over here, 1/6 is equivalent to what number divided by 12? Well, what we did in the past was this. We said 6 times what is 12? Well, 6 times 2 is 12. But what you do to the denominator, you have to do it to the numerator. And so 1 times 2 is 2. And so think about this. Is 2/12 the same as 1/6? The answer is yes. If you reduce it, you get 1/6 back. But just like over here, notice 2/12 subtract itself, that is just 0. So number 12 is just 0. Okay, now let's look at this one. Let's look at one more with fractions in it. So let's suppose we had number 13. So suppose in 13 we had 2 2/3 cubed plus 1/9 plus 1/3 times 4/3. Suppose we had this. So 2/3 cubed plus 1/9 plus 1/3 times 4/3. Okay, so I have a grouping symbol here, parentheses, but there's really nothing I can do inside this grouping symbol. 2/3 is just 2/3. Okay, so next thing we look at is the exponents. I do exponents next because all I have after that is addition, multiplication. So exponents come before any of these other operations. So 2/3 cubed, remember, means this. 2/3 cubed means 2/3 times itself 3 times. That's what that means. So 2/3 times 2/3 times 2/3. So I can't reduce anything here. Nothing's reducible, but so I'm just going to go ahead and multiply the numerators out, and then I'm going to multiply the denominators. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So I get 8 in the numerator here. 3 times 3 times 3. Well, 3 times 3 is 27, so that's 27. And then 3 times 3 is 9. So 3 times 3 is 9. And then 9 times 3 is 27. So I get 8 divided by 27. So that is just this, though. That's just this. So 2/3 times itself 3 times is 8 divided by 27. All right, so I'm going to write everything else over. Let's write everything else over. So do one thing at a time. One thing at a time. That's a 3 right here. Okay, so I have addition, addition, multiplication. So according to the order of operations, multiplication has higher priority than addition. So let's think about what this 1/3 times 4/3 is. 1/3 times 4/3. Well, again, when you multiply fractions, you multiply numerators together, then multiply the denominators. So 1 times 4 is 4, and then 3 times 3 is 9. So this right here is just 4 9ths. So I get 8 27ths plus 1 9th plus 4 9ths. So that's what I get. Okay? Now, just like we did a while ago, right here, you're subtracting fractions. So when you add or subtract fractions, remember, when you add or subtract fractions, you got to have the same denominator. Your denominators have to be the same. So here, my denominators are different. I have 27, 9, and 9. So let's go ahead and find out what the least common multiple of 27, so least common multiple of 27 and 9. All right, 27 and 9. So the smallest number that 27 and 9 will go into is 27. So least common multiple of 27 and 9 is 27. Because 27 goes into 27 and 9 goes into 27. So don't make a mistake and say that 9 is the least common multiple because 27 does not go into 9 evenly. So your least common multiple has to be greater than or equal to the larger number that you see here. So it has to be bigger than or equal to 27. And it turns out that it is 27. So now I'm going to write three fractions with that denominator. So 27, 27, 27. And so I'm going to write equivalent fraction. Remember, use the word equivalent fractions. Okay, well, 8 27ths is equivalent to what divided by 27? Well, since the denominators are the same, the numerators have to be the same. So 8 27ths is equivalent to itself. All right, let's get this one. 1 9th is equivalent to what fraction with the denominator 27? Well, to figure that out, what you could do is say 9 times what is 27? Well, 9 times 3 is 27. But what I do to the denominator, I have to do to the numerator. So 1 times 3 is 3. And it kind of makes sense that 1 9th is equivalent to 3 27ths because if I reduce 3 27ths, they both have 3's in common. 3 divided by 3 is 1. 27 divided by 3 is 9. All right, let's look at this one. So again, same thing here. They both had the same denominator. So 9 times 3 is 27, and so 4 times 3 is 12. Okay? And now let's add these from left to right. So 8 27ths plus 3 27ths, since the denominator is the same, I can now just add their numerators. 8 27ths plus 3 27ths is 11 27ths. Plus, I'm going to do one thing at a time. So I'm going to go ahead and write that other fraction over. And now these two fractions add together. 11 27ths plus 12 27ths is 23 27ths. 23 27ths. And there's your answer, 23 27ths. You can't reduce it. You're done. Okay? All right. So basically what we did here, so notice we used order of operations. We had fractions. We had grouping symbols within grouping symbols. We had grouping symbols as well. We had absolute value to deal with. We looked at the absolute value, the division bar, the fraction bar, acting as a grouping symbol. And then we also discussed the idea of exponents, exponential notation, exponential expression, what a base is, and what an exponent is. Okay, so that takes care of this part of the lesson.